Okay, we have a question here on trigonometry 3D, and in the diagram there, T is a hook on the ceiling of an art gallery. As you can see, T over there, and point Q. There is point Q. S. Oh, sorry. There is point Q, S, and R. They are on the horizontal plane from where three people are observing the hook. Now the angle of elevation, that one over there, from Q to T is X. And then you have the angle at Q, S, R, which is that one highlighted as 90 plus X. And angle QRS. Now QRS is also what? X. But then the length QR is 5 units. And we have TS, which is equal to TQ. Okay, now the first question is to prove that QS is equal to 5 tan X. Now, how do we do that? The best way to do this is to isolate the diagram that has more information. Which diagram has more information? If we redraw triangle QSR. So let's try and redraw triangle QSR. Now, in Q, QSR, right? We have our Q R being 5, and we have our angle S being the 90 plus X, and then we have our angle R being X. So now if you check, according to the sine rule, this is related to that, and this is related to that. You see, how will that information help us? This information will help us in now showing, or by using the sine rule, whereby we have to show, take note that A over sine A equals to B over sine B. So we've already isolated our sides here. The sides that we'll be looking for, it's QS and then what? And QR. So if I may start by choosing QR, and remember the question is looking for proving that QS. So we can say QR all over the angle that is related to QR is what? Angle related to QR is the 90 plus X. So sine of 90 plus X, which is equal to QR. Oh, already we have QR and we've established it, and we're looking for QS all over sine of the angle associated with what? With QS, which is our X value over there. Sorry, my structure is just a little bit small because of the board I'm using. So sine of X. Now, already we're given what? QR. QR is 5 all over sine of 90 plus X, which is equal to QS. s, which we're looking for, divided by sine x. Now, we can simply do a cross multiplication here in order to get qs. And when we do that, we get that qs sine of 90 plus x is equal to 5 sine x. Then we divide both sides by our sine 90 plus x, and we divide here by sine 90 plus x. Then this will divide in order to make a 1, and we're left with qs being equal to 5 sine x over sine 90 plus x. Now, we know that this is a cofunction. Sine 90 plus x is the same as what? So its complementary function would be a cos. Now, sine in this quadrant of 90 plus x is a positive, and therefore it's cos of x. Therefore, we can say that 5 sine x all over cos x. But we already have an identity here. The identity that sine x over cos x is equal to tan of x. And there we get our answer 5 tan of x. That's it. Okay, second part is to prove that the length qt is equal to 10 sine x. Now qt comes from your t, q, and s, and we're already told that qs is equal to ts. So let's redraw that triangle qts. qtx would look something like this. And that's qts, qts. Now qts is a triangle with two equal sides, and we know that a triangle with two equal sides is what? Is an isosceles triangle, whereby the two base angles are equal to the two base angles are equal, of which here we are given angle q, which is our x, and therefore by we know that these two angles are going to be the same. Why? Because ts, we have been given that ts is equal to qs. Now, how will that help us in finding qt? So we've already proved up here qs is equal to 5 tan x. And that means st is also equal to 5 tan x. Now, with that being said, we already can get angle qt using angle t and angle t and qs and angle s. But what is angle x? We know that all angles in a triangle, they sum up to, so angles in a triangle sum up to equal to 180 degrees. And that being said, angle S will be equal to 180 minus x plus x. And this is 180 minus 2x. So in here, we can look at that and we can link it with this qt side that we're looking for, and then we use angle t in here and side qs. Still, we can use the sine rule. Now, how can we use the sine rule? Sine rule says that a over sine a is equal to side b over sine angle B. Now, let's rename our structures. I like to start with the ones that we know. We already know that side QS has been proved all over sine of x is equal to which side that we're looking for? QT all over sine of the angle of S is what? It's 180 minus 2x. Now, you can substitute the values that we have. We have 5 tan of x being divided by sine of x, which is equal to QT, the one we're looking for, all over sine 180 minus 2x. Now, this is the part whereby we do what? Cross multiply. So let's cross multiply. And when we do that, we get QT is equal to, no, not QT, just QT sine of x is equal to 5 tan of x times sine 180 minus 2x. Now, we can divide both sides by sine of x. Sine of x. Now, this and this will divide in order to give you a 1. And you're left with that QT is equal to 5 tan of x multiplied by sine 180 minus 2x all over sine of x. But when we check sine 180 minus 2x, when we check 180 minus an angle is found in all students taking coffee in the second quadrant. Therefore, this reduction would take us back to a what? A positive sine 2x. And a positive sine 2x is the same as 2 sine x cos x, which is a double angle identity. So this means QT is equal to, also we can change our tan here to its normal identity. Tan of x is the same as sine of x over cos of x. And when we do that, we get 5 sine of x over cos of x multiplied by 2 sine x times cos x, from changing that reduction into a double angle. But if you don't want to skip the step, you can just say here this is equal to 5 tan of x times positive sine 2x divided by sine x. Then you can get here, and you divide everything by sine x. So this thing is now a little bit more simpler. You can do the division here. Take the sine x with the sine x, and this divided by a 1, so that you can divide these cos x's. What then is left is a 5 times 2 times sine of x, of which is equal to 10 sine x.